Okay, continuing with exponents. We've talked about negative exponents, multiplication with exponents. Now let's talk about division with exponents. And this all falls under the same standard. We're still working with NC 8EE1, properties of integer exponents. So let's say we have the problem 2/3 divided by 2 to the second power. So let's see what this looks like if we just write it all out. 2 times 2 times 2 divided by 2 times 2. 2 times 2 times 2 is 8. 2 times 2 is 4. 8 divided by 4 is 2. All right, so that's the long way of doing it. If you're familiar with fractions enough to understand that if you have the same number on the top and the bottom and you're multiplying everything together, this only works if you're multiplying everything together and if the bases are the same over here, keep that in mind, we can cancel out anything that's the same. So if we multiply the top by 2 and we multiply the bottom by 2, we're not changing the value, so we can get rid of that. Same with this pair right here. So this 2 over 2. So if we cancel those out, we're left with just 2 on the top. And technically this is 1 times whatever's down here. So 2 over 1, which is equal to 2. We get the same answer by canceling those out. So let's look at how we could do that using the properties of exponents. So if we have 2 to the third divided by 2 squared, basically all we're doing is we're doing the opposite of multiplication by dividing. So instead of adding the exponents, we're going to subtract the exponents. So we're going to find out what the difference is in the exponents. So up here the difference was 1 on the top. So 3 minus 2 is 1. So 2 to the first power is just 2 over 1 equals 2. So you can think about it like this. Any number to a power divided by that same number, again, the base has to be the same, also to a power, could be the same, could be different, is going to be equal to that base to the powers, the difference of the power, so a minus b. All right, if you remember way back when we talked about what was 2 to the power of 0, for example, and I told you that just anything to the 0 power was 1, here's why. If we had 2 to the 9th power, let's just pick a big number, and we have 2 to the 9th power, and we use the property that we just learned, 2 to the 9th power minus 9. 9 minus 9 is 0, so we get 2 to the 0 power. Well, you know from earlier that anything over itself, anything divided by itself, regardless of what it is equal to 1. So 2 over 9 divided by 2 over 9 is really 2 to the 0 power, but it's also 1. So anything to the 0 power equals 1. Now there's some argument about whether 0 to the 0 power equals 1. I've seen it done both ways. I don't think that comes up, but usually it's considered undefined because you would really be if the base is 0, you would have a 0 in the denominator and you can't divide by 0. So some people argue that it's undefined, which is technically correct, but some people just say, no, it's just 1. Let's just keep it simple, but it should be undefined. So let's look at some examples. All right, so in IXL, they're going to ask you to express using positive exponents. So that's a little bit tricky there. So that's why I did this one first. If you'll notice, we have 821 to the third power on top. So we have 821 3 times on the top. And we have 821 8 times on the bottom. So 3 minus 8 is going to be negative 5. So 3 of the 821s on top are going to cancel out. And we're going to be left with just the number 1 on top. And on the bottom, we're going to be left with 8 of the 821s. Now, if you remember a few lessons ago, we did negative exponents. So let's do this using the properties that we just learned. 821, 3 minus 8, make sure you keep them in order, so don't just assume the bigger number goes first, is going to be 821 to the negative 5th power. And then we move this negative, if you have a negative exponent, you're going to move it across the division bar, either up or down, whichever way you need to go to make it positive. So again, we had 821 times itself 3 times on the top, 8 times on the bottom, and 3 of those would cancel out. And we're left with 5 on the bottom. So subtract the exponents. So now let's look at a few where it's going to leave the exponent on the top. So we're just going to straight up use the rules. I'm not going to write 756 times itself 70 times because that would just take forever. However, now that I know I can just cancel out 8 of those, I can just subtract that. It's 756. 70 minus 8. 756 to the 62nd power. And again, that's going to be an enormous number. Your calculator is probably going to give you an error depending on what kind of calculator you have. That number is going to be so large that it's not going to be able to display it. And I think that's why IXL gives these with big numbers. So you can't really, you have to do the property. You can't just do it in a calculator and get the answer that way. All right, last example. Same process. And again, remember the bases have to be the same. In this exercise, they will be. But if this was 809 and 808, to the 7th and to the 2nd power respectively, we couldn't do anything with it other than work it all the way out and then divide those two numbers. But if the bases are the same, we can work with the exponents. So the bases are the same, so the base doesn't change. And then 7 minus 2 is 5. So the answer for this one, simplified and using positive exponents, would be 809 to the 5th power.